Hello, everybody, and welcome to today's session. We are very lucky. We are joined by the School of Physics, Engineering, and Computer Science for a really special interactive session. So, the interactive session for today is the changing landscape of engineering education. I'm going to pass over to Vivek now to take the session for us today. Just to let you know as well, everybody, there will be a Q&A at the end of today's session. So any questions that you have, please post them in the Q&A section that you should be able to see on screen there. You've also got a chat icon. You can start speaking to fellow participants in the chat icon. But any questions, please do post that in the Q&A section. And myself, I'm Jess. I work in the international office, and my colleague Nkosi will be supporting you by answering those type questions. And then at the end of the session, we can have a Q&A. But I'll pass over to Vivek now to undertake the session.
Thank you, Jess. Hello, everyone. I'm just going to quickly share my screen and start this specially designed interactive session on the changing landscape of engineering education. I am Dr. Vivek Ramamurthy. I'm part of the mechanical engineering department at the SPECS school. And I'm also the engineering UG admissions tutor. So the goal of this session is to highlight some of the key changes that we are bringing on in terms of engineering education, progressing into the next decade and beyond. So before I start, I just wanted to query the audience a little. So if you have your phones with you, might I ask you to scan the QR code, or if you're already on your phone, you can pop open a browser on another tab and go to menti.com and enter the code 65492955. We can have a little bit of an interaction. I just have a few questions, and we will start from there. I have my Menti here. I'm just going to start the presentation. So we have 7 participants, 8. I'll just give a few seconds for everyone to join. So just as I said, you can either scan the QR code, or if you are on your browser, you don't have your phone with you, you can go to menti.com on a browser and enter this particular code 65492955. All right. I think we have a good number. Let's get on with it. So as a first question, I'm just curious to know where you guys are from, and if you can use the Menti screen to select or pin the location roughly where you are from, it'll be interesting for us to see where we all are currently from, and it helps me understand the audience a little. Nice. We have one response. Nice. Already all across the globe, I can see. A few more of you are yet to select. It's brilliant. It's lovely to see people all around the globe. Just a few more seconds, maybe, and then I'll move ahead. Okay, so 8 responded. Okay, so we have people from all the continents except for Europe, which is interesting. Okay, so that's really lovely to see. Brilliant. Okay, I'm going to move on to the next bit of interaction with you. I just want you to type in one word that represents engineering for you. Innovation. That's a brilliant start. Design. Aerospace. Mechanics. I love mechanics. Automotive. Oh, another mechanic. Mechanic. Construction. System. Nice. Creativity. Brilliant. You help me out here for the next for the forthcoming slides. That's awesome. Thank you so much. So it is brilliant to see that you have a clear idea of what engineering is about. Have I missed anything? Intuitive. Very good, very good. So I also wanted to see what areas of interest you probably have offers for specific courses. So you would choose some things. Probably I should have had aerospace and automotive there. I understand some of you are enrolled in those programs. Ah, okay. I didn't have enough options here for you to choose, but glad I had the other option. Cool, cool. Thank you. Okay, so I'm gonna skip the Menti for now and move on with the presentation. So here I'm going to talk about the changing landscape in engineering education. So first, what I'm going to talk about is the kind of experience that a student gets in the University of Hertfordshire classroom is remarkably different from what I had when I studied engineering. Things have changed quite a lot, and I thought it is the best platform to highlight these changes. Now you can already see that you have a lot of students working with prototypes, interacting with each other, building stuff in interesting looking studios. So this is becoming the norm of how we learn engineering. So the paradigm of such learning is CDIO: conceive, design, implement, and operate. So it is something that we have developed to bridge the gap between academia and the industrial world. We realized that for a long time, what we learned in the engineering school, in the classroom, solving equations, learning new manufacturing techniques, those did not amount to a workplace experience. So the CDIO way of learning allows you to work together, solve a problem. There isn't a correct answer. You build a portfolio of designs, and you build and operate different inventions of your own in each module. And that is how CDIOs run. So it is to give you an authentic learning experience right from the first semester. So you are working in groups, you are solving an engineering problem, you are building CAD models, you are manufacturing them using 3D printers, laser cutters, and fabricating it hands-on yourself from uh, from 10 a.m. in the morning to 4 p.m. in the evening, 1 day a week. So typically in the undergraduate program, it is 1 day a week you have a CDIO module up to your second year. So in those modules, you you basically build products, and the final day of the semester, final week of the semester, you will be testing them. So that's what we do in CDIO. So you are getting the experience of being in the engineering environment right from the first semester. So when you get a job in the industry, the first day of your employment is no surprise. You've been doing this for years now. So that is the idea behind this concept. So you can see that the classrooms are different. They are group workspaces. So these are some of the photos of our students engaging in manufacturing during a CDIO. So it's really hands-on. So the materials will be provided to you. We have dedicated large design spaces for specifically giving you the opportunity to engage in these modules. We have them in the entire, not the entire, but most of the first floor of the Spectra building, which I'll show you in one of the other slides, where you will spend most of the time learning. So the day typically works like this: 10 a.m. to 4 p.m., 1 day a week. In the mornings, typically you're undergoing a training. For instance, what how you should conceive designs, how you should conceptualize designs. So the general learning is done as in terms of workshops or lectures in the morning, and you have dedicated time to work with your team to come up with a design that you will choose to manufacture. You will refine those designs. You will have access to um, university laptops which you can borrow right at the studio itself. You can just tap in your ID and get a laptop and start working. And in some cases, we actually take you to a separate lab to use the advanced software that are not really that don't really function well in the laptop. So you could be moving, but briefly, from the CDIO space. And the 11th week typically is the competition day, where groups compete against each other, their products compete against each other, and we find out who has built the product to the best of the performance indicators, which we will provide to you during the module. You don't have to take work away from the session. There is no work necessary outside the window of 10 a.m. to 4 p.m. during these weeks. So, well, unless you want to engage in some work outside of the CDO sessions. Typically, you will have enough time to work on these projects. You will build, there will be constraints. You can't bring your own materials. You have to build within, you. For instance, if a project specifies you to use only mechanical fasteners or wood joints, you have to respect that, because we will conduct a scrutineering at the end of the module. It will be fun. all all the CDIOs I teach are the most fun sessions. So here is some note from some of our students.
Hello, I'm Aisha and I'm with Christine. We both are second year mechanical engineering student at the University of Hertfordshire. Today we're going to show you how we spend our day for the CDIO module. The CDIO module starts at the 9 a.m. at the morning. We actually need to build two model arms for this module. One we are almost done and one we are sketching that day. For the one we were almost done, we need to complete all the programming and give a presentation in front of the panel. After giving the presentation by 4 p.m., we're done with the class for that day, and then we can actually leave for home. Thank you for watching.
So this is one of the finally built prototypes. A NEVA mechanism. So,
Hello.
so on the competition day, what happens is we will scrutineer the products you build. This is an example from one of my modules for automotive and mechanical engineers. It is co-taught. So the problem is to build a space frame that will act as the core structure of an automotive. In this particular case, the problem given was to design a scaled down prototype of a Formula E racing car, and these are the winning models in the aesthetic group. Once we have the designs, these are built by groups of individuals again, and once we have those prototypes, we test on the competition day. This is one example of a test where we use a sled launcher.
Pulling the trigger in 3, 2, 1. Here we go. That midsection though, don't lie.
So as you can see, I'll play it one more time.
Pulling the trigger in 3, 2, 1. Here we go.
So as you can see, this is what happens on the test day. Unfortunately, not all projects get taken back home because we crush them. And based on the performance metrics, how safe was the driver's compartment, and all sorts of things. We evaluate different teams, and we give marks on. We assess them based on their proficiency in building. It's not just the group work. You will also have an individual portfolio to submit that differentiates your score as opposed to your teammates' scores. So you have the opportunity to demonstrate your learning separately, and these portfolios are quite useful because these are documents which are sort of in a landscape layout, which you can present to an interviewer, for instance, and show what you did on this module, what project you built, what is the design, what is the reasoning behind the design, what are the conceptual designs you came up with. So it's a document that you build, which is not just for your module's score, but also something that remains as an artifact of your work as part of the module to show into the future in an interview. It doesn't go wasted. So I'm also going to talk about other modules. Not all modules are CDIO modules. So this is an example from my own module on acoustics. The unit is vibrations, and so the students learn how single degree of freedom spring mass systems work. Basically, you have a mass hung from a spring, and you raise it and release it. How the mass moves is of interest to us because that is helpful in designing automotive suspensions, for example. And the way these masses move depends on damping. The symbol here is zeta. And if zeta is 1, the mass actually comes down. So we have, as a function of time, the amplitude, the displacement of the mass, the delta of the mass, which is plotted. And if you release it from 4, it comes to the mean position in a short time. If it is over damped, written as deadbeat here, which has a damping coefficient, damping ratio greater than 1, it comes to rest, but really slowly, relatively slowly compared to the critically damped system. And when you have insufficient damping or under damped systems, it has an oscillatory response. Again, don't worry about it. I'm not here to give a lecture on vibrations today, but rather to highlight the fact that how boring this is. I mean, some things are boring, but we can make such concepts interesting. Now, this has a physical meaning, isn't it? So this is a tool that I've built, and it is online. We have a tool that can help you visualize the motion of these masses, spring mass systems, when they have specific damping ratios. Now, I request you to scan the QR code here one more time, and if you have your phones, it's easier, but if not, you would have to use this link, unfortunately. But I can try to paste this. I can try to paste this. Oops. Let me leave it at that. I will just copy from here, and if you have a phone, you can go ahead and share the scan the QR code. If not, I am going to put down the link in the chat. Here you go. You should be able to click on the link and access the page. And what you can do on that web page is so you should see something like this. On your phones, it might not be as large, but it has the same functionality. Now, this is an interactive web application. Now, what you can do is you can drag the masses and drop them. And you will notice that different masses behave differently. They respond differently when you drag them and drop them. Now, you can drag on the sides to drag all the masses at the same time and drop them, and you can drag between the masses to drag two masses at the same time and drop them. Now, what you can notice is the undamped system, once you drag and drop them, they will keep oscillating forever. And because it's a computer program, the simulation works like this. But no real system has zero damping. They always come to rest after a point in time. And this one with 0.02 damping, 2% damping, comes to rest in some time, in a few minutes maybe, or maybe a minute. One with 10% damping or 0.1 zeta will come to rest a little quicker. One with 0.8 damping, it's coming to rest. It is oscillating. You can see that it is actually overshooting a little bit. If I compare the critically damped zeta equals 1 mass with the 0.8 underdamped mass, you can see that the 0.8 mass comes to rest faster, slightly. Because it overshoots, it seems like it comes faster. It comes to rest faster. But theoretically, if you consider it depends on how much you consider as coming back to rest. Is it to within a millimeter deformation from the mean position, or is it 1 centimeter from the mean position? It depends. But theoretically, the critically damped zeta equals 1 system comes to rest the fastest. So you can see that the zeta equals 2 system comes to rest slower than the critically damped system. And zeta equals 10 system takes a lot of time to come back to the mean position. So what you can learn from this is, how much should my suspension be damped? How much damping should I adjust in the suspension so that when my car goes over a speed bump, it is smooth on the driver's compartment. So that is the question we are trying to answer by understanding damping. And typically, you would notice that real physical suspension systems are slightly underdamped, and I can readily show you now using this tool, because you can see a slight overshoot, but it seemingly comes down faster. It smoothens out these bumps more effectively than critically damped systems, and that's why you would see that suspension systems have one bounce. If you have a car going over a speed bump, if you notice closely, the wheels will just have a little bit of oscillation. It's not critically damped. You can critically damp it, but this is observed to be more comfortable for the drivers. This is true for any vibration application. The seats in an aeroplane, uh, the passenger compartment in an airplane, and a building which is isolated from earthquake oscillations. This is relevant in many different engineering domains, not just automotive suspension. Hopefully, you are able to try this out by clicking on experiencing the tool. Hopefully, you are trying this out as I explained. So that's how education is changing. The point I also want to highlight is, by using such advanced tools, which are not hard to build these days with AI support. Although this tool was not built with the AI support, it's quite an old tool that I built 4 years ago, I think. So it's quite old, but you can build such tools with ease these days, and that means we lecturers are in a better position to support your learning. This just means you are more equipped with the right knowledge. So that is the key highlight of what I'm trying to say. So the engineering education is changing for the better. We are also changing assessments. Assessments used to be heavily reliant on exams, learning equations, and solving problems. It involved more remembering previously. And our own academic quality assurance team is changing things by introducing group practicals, for example, through CDIOs. You build and test a project. You build your own portfolios, which can be used as an artifact for interview purpose going forwards. Those are part of evaluations. Poster presentations of your CDIO project or another project instead of an exam, for example. Instead of a test, you could replace it with a poster presentation. You're learning to communicate with other people, so that is a skill that you need to have in engineering. So in order to reduce the burden of memorizing or recollecting equations, we provide formula sheets for the key formulas in an exam, and the problems that you solve will be more practically relevant. It will be a practical problem, not a canonical engineering problem that's on your test. So we are moving in that direction, and some of these assessments also are conducive to including AI. So we are in a transforming world where AI is here to stay, and we have to augment our capabilities with AI. And you're at a crucial point where things are transforming for the better, and our assessments are also transforming, so that we allow you to include AI use, but you have to declare it, but you are allowed to use. And sometimes for one of my master's modules, I in fact encourage, for the mini project at the end, you use AI, you declare it, but give me a good project. So that is the kind of direction in which this is moving forward. And the reason we do this is you are trained better for the workplace. And we also train you to adapt to how future engineers are going to work. So we are training you for the future. So let's go back to our previous Menti. Again, this is not a different QR code, but the same Menti. If you have logged into that menti.com, you perhaps could continue. But if you haven't, or if you closed it, you can use the link. You can use the QR code here to scan and log into the Menti. So I could already see that there are 15 of you ready. So perhaps I can start now. So just take the moment to open up the Menti page, and we are going to have a little quiz to check your learning. We are not going to put this on your transcript. Don't worry about it. So you would get some questions on your phone and you can answer. The quicker you answer, the more points you get. Are you ready? Let's go. If you haven't joined yet, you can join anytime by scanning the QR code, or you can go to menti.com and enter this number and you will log in. All right? Cool. Let's go. Answer on your phones. Good work. So there are still 5 questions. You can get to the leaderboard. So be quick, be precise. The next question. Good. Perfect. Everyone has got this right. Next question. 4 more to go. Try to catch up. Okay. Between 0 and 1 is underdamped. Good work. Question 4. Brilliant. Ready? So copper is among these options the best electric conductor. One last question. Let's see. Last question, everyone. Quite close, but majority has got it right. Well done. Let's see who is in the leaderboard. Well done, Daniel. And all the others following, you've done a good job. So that pretty much concludes the discussion on changing landscapes in engineering education. So I just wanted to give you a glimpse of the other things that you could do in the uni and some other, um, you know, points of interest that you might be wondering about. So we have our Formula student team, which is very active. They are really hardworking, and so I want to encourage you to check out their Instagram page, which is quite active, and it's quite funny and cool. If you follow F1, the kind of things that you find online about F1, it's the kind of stuff they do as well. So it's quite nice. It's fun. You can have a binge of all their videos. You will see some of the current students in those videos, what they are up to, and it's a little goofy and you will enjoy it. So I've put that in the chat also. So this is how this is a dedicated lab for the Formula students. Pretty much, it is one of our labs, but oh, this is the CDIO lab actually. So yeah, I got confused because usually the racing car is in the dedicated room for the automotive Formula student. So you can engage in the in Formula student right from the first year. There is no limit to it. Masters applicants also can participate. There is no limit to it. You just show up and take up some responsibility and do it. That's it. So this is our recent show at the Silverstone event in the Formula One circuit. And we have a variety of racing and flight simulators and VR simulators that you can experience during your free time. You can just book in. There is a registration form, and you just book in a time when you're available, and you will be able to log in and use it. So these are not all of our simulators. We have several rooms with 20 or so simulators in total, if I'm not wrong. Should get that number. So these are our other design space, not design spaces, but learning spaces. So you can see from the first floor of the Spectra building, and you also have computer embedded classrooms where you can just uh, pop open the computer when you need it and close it down when you don't need it. It acts as a desk. And these are our connect spaces. Anyone can have their lunch here. You can just hang out with your friends, and you can work on something here. So these kind of spaces are available in every floor, and some more labs. This is the CDIO room in the ground floor of the Spectra building. So we have all of these undergraduate courses. You probably are enrolled in one of them, and the master's courses that engineering has to offer. So master's is more focused on research and industry, advanced technologies. So you will be engaged in master's, uh, uh, scientific research with academics during your projects, and you can also engage with projects away from other than your MSc projects. So we have labs to support it, plenty of labs, which I cannot include. And there is a series of all the lab facilities available that you can view once you've got your student account. You can go to HOTS Hub, and you have a dedicated specs facilities page. If you need to use a laser cutter for some project, you can just book in and show up, and you can use the laser cutter. For safety critical equipment, your lab advisor, lab manager will be present, and you will have to submit a risk assessment just to ensure your safety. But you have all of those tools and equipments at your disposal for your projects. So uh, the ideas, you come up with ideas and you walk away with projects. So that's the kind of freedom we offer in engineering. So this is a video on scholarships.
One of my lecturers told me about the scholarship, and I just thought, do you know what, I'll give it a go.
Let me just apply, because first it might relieve me of little financial burden, and I wanted that on my CV because usually it really opens a lot of career prospects. Receiving the bursary, it evoked a lot of emotions. I was really, really excited.
It's nice to have money awarded to you for your own academic achievement.
It helped me a lot in terms of being able to afford certain resources that I needed.
I could go and get nursing shoes that were really expensive that I needed, and it just meant that I wasn't panicking at the start of every term, thinking about how I was going to afford these things. Yeah, it was a lifeline.
I'll tell every student to apply for the bursary.
It's no shame in applying for a bursary or a scholarship because they're designed to help you, and it's nice to have money for your recognition and achievements, and that you don't have to pay back.
Believe in yourself, apply, and you might be surprised.
I just meant to move to the next slide. Okay, so you've already got offers from HOTS. So this is just one of the slides we use on open days. So HOTS is actually transforming the way it's doing things. And you might have read in the news that HOTS has jumped 13 places in 1 year in the university rankings. So we are fast growing. We are closer to London. So if that is something of interest to you, so London is just a 25-minute train away. So our graduates have an excellent employment and further study record. We have inspiring new spaces which have been commissioned, and you can I just have a slide on the aerial view of the Spectra building. So the one here with the glass windows is the Spectra building. The one behind is the LRC. I have another picture. And in this image, we can't see the main corridor, but the main corridor is just behind us. It's not shown in the image. We have another building, right building, where you might have some of your lectures. We have lots of rooms in that building. And we have the Nexus building and accommodation buildings in the background, in the backdrop. You have the Oval, and some sports facilities and the accommodation facilities. So if you are enrolled in the accommodation, the the commute from your place of living to your university is just 15 minutes. From your bed to your lecture theater takes 15 minutes. So that's a really good convenience. And this is the Learning Resources Center. After you join, you might be spending much of your time here. So this is a dedicated learning space that students can use 24/7. You have it's partly it's a library, but we don't usually call it a library. It's a learning resource center because it also has other. We have computer labs in it. You can access the university high performance clusters using those machines. You have advanced engineering software in the technical computer room, and you also have some computer labs which you might be using sometimes. And you also have a restaurant in the lower ground level. You have pots to lie down and take rest. You have meeting rooms. It's a wonderful place to interact with other students and learn. We see during exam time students spending a lot of time in the learning resource center. It's quite useful and students love it. So if you have any questions at any point later, you can always drop an email to ask@hearts.ac.uk. Feel free to do that. And you can also chat with our existing students and staff members on Unibuddy. You can go directly to hearts.ac.uk. When you browse pages, you will see a chat window pop up, and you can chat with our students directly, or you can use the go.hearts.ac.uk/chat. You can also use this page to access the chat. If you forget how to access Unibuddies, you can just go to hearts.ac.uk and you will get a chat window pop up. So I'm ready for your questions and looking forward to listening from you.
Brilliant. Thank you so much, Vivek. That was a fantastic session. I'm just going to share my slides, everybody, just to share my screen. I really enjoyed the quiz. I thought it was absolutely brilliant and so much fun. And I learned loads during that quiz as well, which was fantastic. So thank you so much for that.
Lovely.
So I'm just going to share my slides. Bear with me one moment, everybody. So yeah, any questions you have, please pop them in the Q&A section for Vivek and we can start asking him these live. Whilst we're waiting for questions, I've got a few questions for you that are our frequently asked questions, Vivek. So one of them is, what are your top tips for new international students joining the School of Physics, Engineering and Computer Science?
Topics, if I heard right.
Yes.
I would say if you're in automotive or mechanical, enroll in the UH racing, or if you're from aerospace, enroll in the UH rocketry team. You have to use those opportunities to interact with people, because you learn more from other people. This is not a degree where you attend lectures, you participate in projects and just gain knowledge from that. It's also developing yourself to interact with other people and work towards a common goal. I would say just tap into the resource that's available to you. So it's the students, other students around you, your seniors. You can mentor junior students. It's quite a useful thing to do, and engage in other co-curricular activities like these.
That's brilliant advice, Vivek. I really like that. What kind of like clubs and societies are available for our engineering students? Again, this is a frequently asked question.
Okay, so again, as I said, the students society, the student so they have a lot of events going on. you can participate in those clubs. You can become a member of those clubs. Unfortunately, I'm not aware of them because those are just student focused. So um, other than that, in terms of the engineering clubs, we have the UH racing team and the UH rocketry team, and I'm sure each engineering uh, subject group will have their own co-curricular team. For instance, the mechanical team has the IMechE Design Challenge team. So all of these engineering programs are accredited, and they have some challenge that the students work towards. One such is the UH Racing, the Formula Student Challenge, the Rocketry Challenge, and the IMechE Design Challenge. You have that from the professional bodies. So you would typically have a club in every society, robotics club, and all the programs. So you can there is no barrier to enrollment in these co-curricular clubs. So I will say join early and make the most out of it, because when you attend job interviews, you can write that in your CV, so you have participated in these co-curricular teams, and you build something, and that actually matters uh, more than you think it does. So it shows that you are passionate. It shows that you have learned the skills. It's not easy to build a functional race car to the specifications uh, that the Formula student prescribes. So it's quite a challenge, and you will learn quite a lot doing those, taking up those roles.
Perfect. Thank you so much, Vivek. I've got a few more questions coming in. I'm going to answer this next one. So someone said, is it possible to get a scholarship on a football academy? So for international students, we do have a range of scholarships available. So if you have a look through on our scholarship page, on our international kind of pages of the website, you can see the full listing. Obviously, if you're an undergraduate student, you'd be entitled to the UG Triannual Scholarship, which is £2,000 off your tuition fees each year. And if you're a postgraduate student, then you're also entitled to our early bird discount as well. So have a look at our website to see the full terms and conditions in relation to that as well. Now, Vivek, I've got a question for you. Someone's popped it in the chat, and thank you, Nkosi, for reminding everybody. We'll just post those in the Q&A section. But this is a great question. So someone said, for a student undertaking BSc in aerospace engineering with pilot studies, how does the university help students attain the flight hours needed for graduation?
So I would suggest asking that to Joanna Rauska, because I've had this query from one of the prospective applicants, and our aerospace staff member Joanna has a clear answer for that. And if you so it so the flight hours, so the university supports you to enroll in those training sessions, but the pilot's license requires specific number of sessions being attended by the student. So that is paid by the student, but the support from the uni to approach them is provided, and those training hours count towards the assessment for the degree. Perhaps it is best to get the answer from Joanna, because she has more information, and I could probably send to Daniel here the email that I've received from Joanna with the information. I can't recollect it exactly from my memory.
I imagine as well, when students are registered onto the programme, they would be given that full advice as well, wouldn't they, Vivek, of like how the
Yes,
university would
absolutely.
support them.
It'll be discussed during the induction sessions.
Perfect. That's fantastic. And that's really great that people are being so organised. But yes, don't worry, everybody, you will get told that information once you're enrolling at the university as well, and finding out, how we're supporting you and what requirements you need as well after graduation. So I've got another question here that someone's posted, and they've said, what skills should I focus on during the course if I want to become an AI and robotics engineer?
So in terms of learning so the university provides you with a strong foundation in the first year and scaffolds it as you progress into the second and third year. Ideally, you can use the summertime to take some rest, or if you want to brush up some concepts, I would suggest linear algebra and other math concepts, which can be quite useful um, for AI especially. And if you have access to a CAD application, you can build your own. The more practice you get, the better you get at using these tools, and you will just generate the CAD files in such a short time if asked. So I would say practice those CAD skills, because robotics also requires you to design systems. And I will also suggest, if you have never done this, learn Arduino. So Arduino is this public accessible toolkit which you can buy for 25 pounds or so. You can get a kit and you can start building electronics projects. You can build control projects, and you can also explore Tinkercad. Tinkercad is a page that allows you to simulate the circuits that you can build, and so you can just connect those actuators yourself. It's almost as if you build the circuit physically, so it allows you to do that. And these are more than sufficient, I would say, at this stage, because by enrolling, you've already proven that you can manage the course of the content of the program. So it is not required, but it is good to practice, and if possible, Tinkercad, because you will eventually learn them. If you practice more, you get better at it.
Fantastic. Thank you so much, Vivek. Great advice for our offer holders today. So thank you for that. So everybody, I can see that we've answered all the questions in the Q&A section. And this is now the end of the session today. So I just want to say a massive thank you to Vivek for a fantastic session. And thank you everybody for joining us today. Now, Vivek did provide details about the Ask Arts team. So once you're registered, absolutely the Ask Art team can support you. Whilst you're an offer holder and an applicant, please do contact the international office and we can support you. So you obviously got our website there, our email address. You can contact us by phone, by Instagram, by Facebook, and by X as well. So lots of ways to contact us. But thank you so much, everybody, for joining us today for this session. And we're really excited to welcome you all to the University of Hertfordshire in September.